So getting confused about domain and range is something that pretty much exists at all levels of math. It doesn't go away no matter how advanced you get in math. So this is going to be a quick few-minute talk on just getting a better gut sense for what domain and range are, and hopefully make it easier to remember which is which. Anyway, in math, you usually start by studying the relationships between individual numbers. And you can do that with exponents, you can do that with multiplication, addition, a bunch of other fun operations. But often in biology, computer science, and in math itself, you need not just to understand the relationship between two individual numbers, but you have to understand a relationship between two lists of numbers. And so here I wrote out two lists of numbers that have a pretty simple relationship. There's the left list and the right list, as I've called them. The left list is just the numbers 1, 2, 3, 4, 5. And the right list is the numbers here doubled with 1 added to them. So if we take 3, we double it, we get 6, add 1, we get 7. Same thing, 5, double it to 10, add 1, you get 11. So the right list here, easy way to think of this is almost as if you're like cooking. So the left list, the one you start with, and that's called the domain, that's like your ingredients. The function or transformation in between the two lists, that's like your cooking technique. So that's like baking, boiling, chopping, frying. And then the right list is the food that you actually produce by your cooking. And in general, here for this list, we could write down what's going on with a kind of general rule instead of writing out the connection for every single thing on the list by just saying that a number x is sent to 2x plus 1. And then you could label the numbers in the right list here with f of x or y, just depends on what the context is. And so when you're studying those relationships between domain and range, ingredients, cooked food, between the inputs and outputs of a function, instead of lining the lists up like right next to each other, it's usually easier to try to like form some kind of graph. So what you do is you take one of the lists and you like flip it down on its side and then try to get a visualization of what's going on with the list. So y'all are familiar with the idea of a number line, the idea that you can visualize numbers by laying them out in a line one after the other. And so what you can do is you can take a number line for the left list and you can flip that down horizontal. And you can take a number line for the right list and that kind of just stays vertical. And now you take the numbers in your inputs and you move them up to the height of the same number that they are, you could say, sent to by your transformation. So for instance, in this transformation or function, whichever you want to call it, 2 is sent to 5. So on this visualization here, the number 2, we're going to send it up to the height of 5. And this is what graphing is, essentially. So we have the left list or the domain horizontal. You could do it the other way around, where instead of flipping the input or the ingredient list down on its side, you could also flip like the right list, the range down on its side. But it's just kind of traditional to put the domain flat and the range vertical. And so here, this relationship, 2x plus 1, might look familiar. It's in the shape of a line. So y equals mx plus b. Here m is 2 and b is 1. So sure enough, the points that we've graphed in this way form a perfect line. And usually the line goes off endlessly in both directions. But here I'm just going to draw it in from 1 to 5. And now if you drew this in, the domain of this function, so that means the possible ingredients that we're throwing into it, are the numbers 1 through 5, 1 and 5 included, so we have little square brackets. And the output, or the range, is 3 up through 11. 3 and 11 both included, so we'd say brackets for 3 and 11. And then usually, and this is what you'll see on your tests mostly, this line shoots off endlessly in both directions. And so if it's shooting off endlessly left and right, the domain is now going to be negative infinity to positive infinity because the line is going to stretch off in both directions endlessly. The only way that the domain would not be negative infinity to infinity for a line is if that line was perfectly vertical. Because then the domain would just be, whatever point was directly underneath the line. And then similarly, if we take this diagonal line, send it off endlessly in both directions, it's also going to stretch endlessly upwards and downwards. And so the range for this line would be negative infinity to infinity. So this raises one slight other important point. The domain and range of a function don't just depend on the mathematical manipulation of numbers that you're doing. In this case, f is what I'm calling it, for 2x plus 1. It depends on what the input and the output are. Similar to how, like, if you're cooking, the dish you produce in your output isn't determined just by the cooking steps you use, but also by which ingredients you use. And that's a quick understanding of domain and range.